blockchain event presented to you by MSAC KIIT and in association with KIIT KAKSHA. After successfully completing this event, what just happened? Okay, sorry. Okay, I'll start again. So, hi, I'm Ananya from MSAC KIIT. We're glad to have you all here for this 1 hour power-packed blockchain event and presented to you by MSAC KIIT and in association with KIIT KAKSHA. So, after completing the workshop, all the participants will receive Microsoft UNCONFIRM Ambassador Authorized Certificate. So, our guest for today, blockchain technology consultant Neha Kaushik, will give a broader light on the topic and further continue the blockchain workshop. Neha, on the board, guys.
Hello, everyone. Thank you for having me here. Is my screen visible to everyone? If somebody can tell if it's visible.
Yeah, it's visible.
Okay. So, with 1 hour in my hand and your all long-awaited Sunday evening, I really don't want anybody to be disappointed and dissatisfied at the end of the event. And to make sure that it does not happen, I've prepared a load of things for you guys, along with the ability to decide what and how we will proceed with it, right? And so before we proceed, just do make sure that you have pinned the chat box out there, and feel free to use it as per your discretion and ask any doubt if you have. So I more or less know what is expected of me this evening, but I really don't know how to present it any differently than others. So please help me out whenever it is required. I'll be asking you guys how we can proceed with the event. So let's get started. So blockchain that we see nowadays, okay, blockchain. I'm sorry, but I'm not able to see the chat here. Is there any way I can see the chat so I can answer the questions if there are any? Hello?
Ananya will be telling you the questions whenever they will pop up in the chat, so you can answer them that way. Cool.
Okay, sure. All right. So before we start talking about blockchain, let's talk about something that probably all of us already know about. Not if not used, then probably at least heard about. And that is the Bitcoin blockchain. Now, cryptocurrency as we see it today is something that has been, laid down in early 2000s and late, it's somewhere around 2008 that we find the concept of blockchain rising with the help. We will be discussing everything. So all of you are aware, I believe, about cryptocurrency. Just a quick yes or no, or should I go and explain what cryptocurrency basically means? This event is going to be a little bit on technical side, and I'll be explaining the technical aspects of blockchain along with the conceptual understanding of what blockchain means and how the entire concept of decentralization revolves around it. Now, it's just, Ananya, can you please tell me, and if all of you guys can just type yes or no, do you guys know what cryptocurrency is? Okay. Are there any responses?
Yeah, just one, yes.
So, since it seems that you are aware of cryptocurrency, so Bitcoin, firstly, is not the only cryptocurrency. If you have this in mind, there are various other cryptocurrencies, and all of them have laid foundations to some very fundamental concepts that we have today about how we perceive decentralization. Now, blockchain allows us to question some of the very fundamental concepts that we as individuals have perceived as established notions, like currency, like your trading, like your finance, your e-commerce. All of this have been established in a form of a concrete foundation in our brains, and it's have been engraved in our mind. What blockchain allows you to do is rethink about how it all works, be it Ethereum, be it IOTA, be it the Ripple network, be it your Linux Foundation Hyperledger. All of this is then again questioning what we perceive as something common and something natural to happen. Now, there are various terms associated with it when we're talking about blockchain and we're talking about cryptocurrencies together. So first and foremost thing that all of you should take away from this workshop is that cryptocurrency and blockchain, both of these terms are not interchangeable. Blockchain is the underlying technology behind cryptocurrency. Cryptocurrencies are extreme. Like, what is the difference between a normal currency and a cryptocurrency, like the paper currency that we have? When we're talking about cryptocurrency, we do not have a centralized bank there. We do not have a centralized government, like government or any institution for that matter, who's controlling the flow of income in the network. It's somewhere somewhat decentralized. Like you and I both, if we are part of a network, we both have equal opportunity to actually create the currency out of thin air and transact it with anybody and everybody down there. So it's the same as saying that cryptocurrency is like your application and your blockchain is like your mobile platform. Now, your application can be anything. It can be Ola, Uber, Zomato, and your blockchain can be iOS, it can be Android. I hope you got the difference. And please remember, both of these terms are not at all interchangeable. There are a whole lot of technicalities involved in it. And cryptocurrency is just an example. Now, let's get started with there is a story of blockchain did not go back very long. Doesn't really. Is somebody trying to say something?
Yeah, excuse me.
I'm hearing some noises. Probably it was. So
I,
the
I,
story of
I,
Ananya, can you mute this?
Yeah, but the name is Dhruv Kaushik, so I'm confused.
no, that's because I'm
Yeah,
using a
that's you.
different.
Okay, I think. Okay. Yeah.
Yeah. So the story of blockchain does not really go back very far in time, but it really does go back to 1990s. And I won't bore you with the entire concept of history and everything. But it was then in 1990s that people started questioning how can we secure our past? How can we make it so that nobody can change it? And how can we have a more perfect future, more a tamperless future, and a more it's a future where all of us have the same power on history. Now, in 2008, what happened was something very phenomenal to what how we perceive blockchain. When Satoshi Nakamoto, the shadowy figure in the story of blockchain, he first set up Bitcoin blockchain in motion in January 2009. And he stimulated to very radical and untested, unprecedented concepts. Firstly, was of blockchain and Bitcoin. What Bitcoin does, it's a decentralized network, which basically means that nobody has any authority over the network, and everybody and nobody is trusted more than anybody else. And it's a peer-to-peer network. That means you're connected to everybody around the world, and it's an online currency as well. What he did was the genius of Satoshi Nakamoto. He collaborated the concept of blockchain and the currency, and he gave it some value. Now, the second concept that Satoshi Nakamoto brought into picture was the concept of proof of work. Now, proof of work was there since early 1990s, but it wasn't implemented. What proof of work basically means is that when we do not have any central authority to trust, then who are we trusting? Like, for example, if we are together in a network and we want to exchange something, then who is going to validate all these things? That was so they came down and it all boils down to a consensus protocol called as proof of work. Now, proof of work is not the only consensus protocol that is out there, but it is uh, the first one that came into picture. So after 2008, 2014, we had Ethereum, and now right now we are questioning the fact that why is there so much interest in decentralization anyway, when everything is working perfectly fine? So one thing that you should all remember here is that blockchain is a very complex technology. It's not only a technology, it's an economical and a social phenomena as well, which allows us to question the perceived established parameters of modern world. Be it your trust, how we trust each other, how we communicate with each other, and how we exchange values in general. So This is why the concept of blockchain and decentralization is so important. Now, blockchain means a
Excuse
lot,
me.
many different things. Yeah, sure.
Yeah. So you said that for blockchain, no one has authority over blockchain, right?
Right.
Because it's decentralized. So theoretically, if I want to gain authority over say Bitcoin blockchain, then how can I gain it?
You want to gain authority over something that is decentralized. Is that what you're asking?
Yeah, tell me, is it possible? I mean, it is definitely possible because there is a theoretical way to gain. Theoretically, there is a way to gain control over say Bitcoin. So, can you explain that method? How it can be done?
Yeah, I'll be explaining that, but in a later time because it is there in what I've prepared for you guys. But just to answer your question quickly, yes, you can gain the control, but it is practically impossible. You can do it. There is something called as a 51%, attack. It said that if you get control over 51% of the entire network, you can get control over the internet and with the blockchain itself, right? But that is not practically possible. And to counteract that, if you have heard about the term Ethereum 2.0, so we have various changes in the protocols. Now we're not using proof of work as a protocol, we're using proof of stake as a protocol, and there have been various, roll-ups and all, which make sure that this thing does not happen. So, did you understand what I'm trying to say? It is
Yeah,
not
definitely.
possible. Yeah,
Yeah.
so we will
So,
be talking about that
by the way,
later.
as you mentioned Ethereum 2.0, so are you trying to say that if the technology that Ethereum 2.0 is going to use using that, we can avoid this kind of 51% attack?
Yes, we can avoid them.
I see.
Yes, yes.
Okay,
You can
please
learn more
continue.
about Ethereum 2.0. Yeah, sure. So for those of you who we left out in the conversation that just happened right now, we will be discussing everything in detail. But since a lot of you might not know what blockchain is about and want to learn how blockchain works and what it is all about, I'll be starting from very basics, right? And please do comment if you are finding the conceptual understanding not very up to the mark, or you want to move to the technical aspect, or you want me to show you some demos out there, the demo of how blockchain works and how blocks are in real life, then please write it in the chat box. So blockchain for developers, you see a lot of people have different use cases of blockchain and they like to define it in the similar fashion. So for developers, it is a set of protocol and encryption technology for securely storing the data in a database which is distributed in nature. When we're talking about businesses and finance, they like to call it as a technology which is behind the growth and development of your cryptocurrency. And along with it, they like to define it as a distributed ledger. Now, what is a ledger? Ledger is basically a fancy term for diary writing, diary keeping. So what businesses do is that they maintain a record of what are the transactions they're doing, what are the records they have. That is what they call as the ledger. And distributed ledger basically, as the name suggests, it's distributed in nature. Now, socialists and reformers like to define blockchain and its concept as a tool for radically reshaping the society and economy and taking us into a more decentralized world. For technologists, it is a driving force for Web 3.0. Now, if you want me to, I can elaborate more on Web 3.0 and clear all your doubts there. But what it essentially means is that internet as we perceive it today is very much centralized, and there are various drawbacks that comes along with it. What blockchain aims at doing is it disrupts the disruptors, disrupts the entire concept of centralization and redesign the internet itself. Now, so how do we define blockchain as developers, as engineers, or as somebody who's trying to understand the technology? Now, blockchain is a platform that combines the encryption and decentralization, I'm sorry. On basic level, it is a new class of information technology. For the first time in human history, people around the globe can trust each other. They might not trust each other individually, but they're trusting the mechanism that is out there and helping them transact with each other. Now, let's come to the classification of blockchain because all this is quite theoretical and you might not be interested in it, but as we're talking about blockchain, it's important to understand what are the typical types of blockchain and all these concepts. Now, we have three types of blockchains, broadly speaking, your public, private, and hybrid. As the name suggests, all of this is, you can talk about public blockchain. Here we have examples of like Bitcoin and Ethereum. In public blockchain, there is no authority and there is no restriction on the participants and the validators. You can be a participant and a validator, just you have the equal opportunity as anybody else in the network. And public blockchain are uncontrollable in nature. That basically means that no body have a complete control over the network. Now, moving on to the private blockchain, as the name suggests itself, here participants needs to be invited. There's something called, if you remember the second slide that I showed you, we have something called as Hyperledger Fabric. It's the Linux Foundation Hyperledger Fabric. It's a very good example of how private blockchain works. You can read about it later on. And then comes the hybrid or consortium blockchain. Now, this is something very different from the rest of the blockchain. What happens here is that some of the nodes, what are nodes there? So nodes, participants, peers, these are all same terms referring to the participants of the network, right? Your phone, your mobile laptop, and everything can be a node. Now, what happens in a hybrid blockchain is that you have some blocks which are private in nature and some are public. So who are private and who are public? Public nodes are the nodes which have access to the blockchain. And private nodes are the nodes who are doing the task of validation. This is the type of blockchain which you can see, like for example, a Ripple network. It's a very good example of consortium blockchain. Now, moving on, let's understand how blockchain really works, right? So this is somewhere you should pay attention to if you really want to know how blockchain is working right now. Let's take, for example, we have a block and it has a color Z to it. Now, if you're probably using HTML or even if you're not knowing about HTML, you'll know that there is some sort of number associated with every block that is out, every color that is out there. Now, for red, it is something around FF 3333, right? So this is a unique fingerprint of that particular color. When we're talking about red, we're talking about FF 3333. It's a particular, you can call it an identity number. Now, in real life as well, blocks have something called as identity number. It's a number, but let's look alphanumeric. It's called a hash, a block hash. We'll talk about that later. Now, let's say we have a set of transactions as well, and they have some color associated with them. Let's say yellow. And now yellow as well have a particular number attached to it, which identifies this particular shade of yellow. Now, what will happen if you mix both of them, right? Now, when we're talking about blockchain and when we're talking about immutability of blockchain, it arises from the fact that the current block, the current concept of your set of transaction is coming from the previous block, right? How this works, I'll explain you in a minute. Now, if we mix red and we mix yellow, we're probably going to get some shade of orange, right? Now, this is something very similar to what happens in real life in a blockchain. If you have a hash, this hash, and this hash, what will happen if you hash them together to get a different hash? You'll probably get something like this, right? Now, let's say, for example, you have another set of transactions or another set of records. And it also has a very different, unique fingerprint associated with it, a unique identity associated with it. And when you combine both of them, you're probably going to get some other shade of green, right? Your blue or gives you green. Now, you get the point how it is working. We are basically combining the past records, hashing them or mixing the colors with the new data that we want to enter into the block. So you get the point how it is working, right? Now, what will happen if somebody goes back in time and tries to change something in the block? Now, how will we change it? Something like, supposedly, I don't like this number and I'm trying to change this 7 to 8 or any other color. But that would be a reference, a fingerprint of some other color. So let's see what happens when we try and change something here. We will get some different shade of blue. Now, if we have a different shade of blue, then we are probably not going to get this block and this block becomes invalid. What I mean to say here is that initially when we had a lighter shade of blue and this orange, that is basically the hashes. Now, if the hash of these blocks are changed, then the new blocks that are added to the chain also become invalid because that's how it is. You don't get this color when you're mixing this two. So that means that this does not even exist. We're getting the point, right? Is there any doubt here? Because this is very
Yeah.
fundamental to how can we make it. Yeah. Hello?
So well then, well, how about this? Instead of going back into the chain, how about we make a fake transaction at the very end of the chain? Like say the next block which is going to come, block n plus 4, we are going to make it as a fake block. Now how we are going to counter that?
That is done by help of consistency. Everything, what we're talking about is very simple. Whenever you have a fake transaction, it firstly needs to be verified by everybody in the network. Let's say if I have to send you 20 rupees and I don't have them, then I cannot send it to you. What happens in a digital world is it's very easy to, copy paste and create replicas of everything and anything out there. So in order to do that, what we need to actually obtain is a consensus protocol, which I had talked about earlier, right? So in order for you to make a fake transaction and for it to actually be verified, it happen. Why? Simply because your transaction is not valid in nature, and the rest of the blocks are going to reject it. So how this happens is, I'll tell you in a second. So what is happening here? I hope your doubt is clear, right? I'll explain more now. Is it clear?
Okay. Well, let's say it is clear.
Okay, I'll explain now. Explain in greater detail, right? Because some of the people might not be able to relate it. If you have a transaction, firstly, it should be verified. We'll see what happens to a transaction just in like a few seconds. Now, this gets combined with a group of transactions. We call it a pool of transactions, and then that gets verified. And once a block is verified, you hash all the transactions together and you form a block. Now, once a block is verified, it gets broadcasted throughout the network. Now, what broadcasting basically means that every node in the network will have the same copy. They will have only one and one source of truth. That would be the current existing block. Now, what will happen if somebody tries to change anything in that? So, if you try to change the latest block, then all of the rest of the nodes will be able to identify that there have been some changes done. Because this is where the 51% attack that the person was asking came into picture, right? Because if 51% of the block says that it is true, then it becomes true. But it's not practically feasible. Now, moving on, let's see what happens to a transaction and why you cannot have a fake transaction. So, firstly, a transaction is validated. What do you mean by validation? Basically means that you have enough transaction fees and you have enough funds to send a transaction, and that you're not a malicious person. There are over like 20, 25 parameters that are checked. Now, I'm sorry. So two things can happen whenever we're validating a transaction. Either it can be a fake transaction and it can be rejected, or it can be a valid transaction. Now, a valid transaction need not be a confirmed transaction. These are two different aspects, right? If I want to send you 20 Bitcoin, then me being able to send those 20 Bitcoins, maybe having enough funds will be validation of that. But you receiving those 20 Bitcoins would be the verification of it. That we have confirmed that you have also received all the money that I had sent you. So all of the valid transactions are first, combined together in a pool of transactions, and then the selection is done basically based on the timestamp. And then the miners. Now, here a very important term that comes here is the miners. Who are miners? Now, this is where I would like to ask you a question as well. Miners are the people who are validating the transaction, who are seeing that if I actually have 20 Bitcoins to give it to you, and if you've actually received 20 Bitcoins, bitcoins or not. So how isn't this very contradictory to the fact that we are talking about decentralization here? I'll tell you that it's not true, but if you have any opinion, please do write down and we can have a discussion over that as well. But why are we trusting these miners? Why are we trusting people to validate our transaction? Why are we trusting them? We don't even know them. So if you have answer to my question, then feel free to answer it in the chat box as well. That why are we trusting the miners and how we can trust them? Because it's a decentralized world. You don't know who is mining your transaction. Mining basically means validating your transaction, that if your transaction is valid or it's not valid. Now, once a miner solves a puzzle to, get the claim, get the right to mine a block, and which in turn means that once the puzzle is solved and the block has been mined, the new block is created and it's been added to the chain and broadcasted throughout the network, as I told you earlier. Now, what happens? Before we move on to a real blockchain, if somebody can answer, how are we trusting the miners here? And why are we trusting the miners here? Who are these people? Is there anyone who knows about that already?
Well, that is because they have given a proof that they have performed some work.
Yes, they've given a proof that they've performed the work, but you don't know those individuals. So how can you trust them in a network?
Well, is it necessary to trust the person or is it necessary to trust the work? I'd say we should trust the work because if they have given.
Absolutely, absolutely. You're absolutely right. The important point that I want to make here is that individuals do not, as member of networks, never trust any other individual. It comes naturally to us that we do not trust them. Now, if we're trusting some miners, we're trusting some validator, we're trusting a human being who is out there somewhere in the world and who is validating if I have the enough funds and if the other person is receiving it or not. So this is where it all comes into picture. We're not trusting any individual. We're trusting the mechanism that is being put into place by the network. I hope it's clear. Now let's look at a real blog. Now this blog has
By the way, see, I have usually seen people saying that they keep proof of this work and they solve this puzzle. But the main thing that I would actually like to know, because this is something that even I was not able to find on internet. What is this puzzle thing that they are talking about? Is it some kind of jigsaw puzzle or something?
no, it's not a jigsaw puzzle. I, I'll tell you, it's all about hashing. See, it comes into a very technical aspect in there. But since you're asking me right now, I'll tell you briefly about it so we can proceed so other people don't get really confused about what we're talking about. So the puzzle that I had mentioned is for Bitcoin, it basically means that you see there is this block hash thing. I hope you can see it, right? So this is
Yeah.
also it looks like an alphanumeric string, but it's actually a number. It's a hexadecimal number. So what happens here is that the puzzle that we're talking about in terms of Bitcoin. Let's talk about Bitcoin blockchain and Ethereum blockchain because these are the most popular blockchains out there. Now, what Bitcoin blockchain does is that it will ask you to generate a specific number by including the previous hash, like we were including the red color and the yellow color and mixing them together get an orange. Same thing happens here. Now, whenever we're talking about a block, we have some data and we have some previous hash. What we are trying to do is club them together and generate a new hash. Now, this new hash is the puzzle that we're talking about. This new hash is something that should fulfill some criteria. For example, for Bitcoin blockchain, it should have 19 leading zeros. And the value, the hexadecimal value that we have here, it should be less than 2 to the power 120. Now for Ethereum, it's a little different. For Ethereum, we talk about difficulty and all. Like we'll be talking and going into further details later on when we're talking about mining and how mining is done. But for now, please understand that this hash needs to meet a criteria. And that is done by, again and again, brute forcefully, you try different variables and try to come up with a solution. And that is the puzzle that we're talking about here. I hope it's understandable what I'm trying to say.
Yeah.
You've understood, right? The one who asked questions. Yeah, okay. So when we're looking at a new block, when we're looking at a real block, this is a block which was created at, at height 671,945. So what it basically means is this is the number of the block, right? Now, there is one more, there's always a special block in a blockchain called a Genesis block. Now, what a Genesis block is, that it is a block at height 0. At height 0 basically means that it is, the Godfather block and all of the generations follow them. So similar to that. Now we have something called as a height in blockchain. We have something called as transaction count, which basically means the set of transactions that we have clubbed together to form the data for the block. Next, we have difficulty. We'll talk about difficulty and nonce. For the timing, let's understand that nonce is a variable out there somewhere doing something, and we'll talk about that later on. Next, we have a timestamp. Timestamp is basically telling you when and how things are working. And then we have a block, a previous block hash, and a Merkle loop. Remember if you remember the yellow color transaction block that we have. So where did that yellow color and the fingerprint of that yellow color came from? It came from this Merkle free hash. And we're combining it with the block hash, previous block hash. They're like both of these entities, this one and this one, are combined together to get this one. Now there are other variables and other factors involved in getting the block hash, but this is the general concept out there. Now let's see how link is established. Now we have something 45 height of the block, right? Now let's look at the hash of the block right here. Let's see what happens when we move a height ahead. Like how by height we're meaning to say that there is a chain, there's the next step. That is what height means here, right? It doesn't mean anything else. It means the next block, the next block number. Now this block is present at 9046. It's the next block, and it also has a block hash. So if you notice carefully, you'll see the previous block hash right here is the hash which is used here, right? Now, in similar fashion, we have 947 out there and the block hash associated with it. How do we get this hash? We hash this entire block with the Merkle root and some other variables, and something happens. We'll talk about what happens later on because it will get very technical now. Now, this is the previous hash. Now, you can see it ends with B82 and it's also like B82. This is how links are established on blockchain. Now, moving on, this is how you got your yellow colored box. How did you get that? I hope you remember the example that I told you earlier. And this is the transaction as we are hashing everything together to make the Merkle. And you can read throughout this presentation, you will get some very nice online resources. You can get their links that I have mentioned it throughout the PPT. Just go there and you can have it for yourself. And this link belongs to the white paper of Satoshi Nakamoto, which he had published in 2008. So go there and read about it. If you have any doubts, you can just check whenever you want. Now, these are some fundamental concepts, although they might look like they just came directly out of your philosophy class, but that isn't the case. Trust me, trust, peer networking, immutability, consensus, decentralization are very core to what we imagine ourselves in future. Now, what we think of our future as is something where nobody has control over our data. Now, things get a little complicated here when we start talking about decentralization because it's probably the poorest defined word and most misunderstood word as well. Now, Vitalik Buterin, the founder of Ethereum, says that decentralized is probably the poorest defined word out there. Now, the current internet looks something like this. You have a server and you have loads of nodes attached to it. Now, what happens is that you connect to your server and you get all of the benefits that are out there for you. Now, this comes at a price. This comes at a price of a high bandwidth required for the server and as well as a central point of failure. What do I mean by central point of failure? It basically means if something goes wrong here, then the entire node and the entire set of nodes goes down and everything gets stopped. There's no way you can do anything about it. So let's take an example, a real life example, except for internet on how it works. Let's say you have an individual A and an individual B, and A wants to send some money to you. How will they send it? You contact a bank, and the bank contacts the B's bank, and there's a transfer of money. Now, this is where this single point of failure comes into picture. That if some malicious activity happens in your bank, then everything goes down. Now, do you want me to elaborate more on centralization, or is it understandable? Just a quick response, if you can.
Yeah, it is definitely understandable, I guess.
Yeah. So centralization comes along with great many, problems. Firstly, the central authority may not always be trusted and can be something that uh, can be tampered with. So when we're talking about decentralized world and distributed networks, there is no central authority there. So even if in a network of 100 nodes, 8 nodes go down, you still can work on 95 nodes. Now there is this very beautiful article on Ethereum stack exchange which you can look at if you want to learn more about decentralization and distributed networks. So let's talk about something which we all question every now and then. What is so wrong with decentralization anyways? Because right now everything seems to be working fine. Right now your banks are working fine. Right now your internet is also working fine. We can transact, we can do anything. So why is there so much interest? Why are people talking so much about Bitcoin these days? Decentralization, in my opinion, is a paradigm shift. Internet as we have it today is controlled by a few internet service providers and few big companies and oligopoly, where you have companies like Facebook, Twitter, retail banking accounts, and we pay like billions of dollars to those people to provide us with this service and the products, which quote unquote we have free access to. Now, please remember that nothing comes for free, and this is what we like to call as digitization campaign. In centralized world where we aim to achieve, we have control of our own information, we have control of our own reputation in the network. Generally speaking, centralization of power can result in companies like Facebook, Amazon, and Google finding ways to monetize your data. But it's your data. Why are they getting benefit out of it? That is the question that we try to answer when we're talking about blockchain and we're talking about decentralization. So this is what usually people perceive internet to be like. Users of popular free services may think of themselves as customers when they're consuming the product and the services associated. But it's actually the other way around. It's you who is paying them for providing you the services. And there are times when you yourself are the product. There are times when we actually have to, log into their accounts, feed in our personal information, and they can do anything whatever they want with it. This is a significant shift in thinking about how we as individuals are talking about decentralization and blockchain in today's world. So what blockchain allows you to do is, what decentralization allows you to do is have control over your data. It allows you to have control over what you are doing and what information you want to share. Now, I hope it's understandable. It's nothing difficult. So whenever we're talking about blockchain, there are a few terms that are associated with it. And please understand that decentralization is not a one-way thing. It's not unidimensional. We have multiple types of decentralization. And blockchain is politically and architecturally decentralized, which essentially means that there is no centered source of information, there is no centered truth to anything, but it's the truth of the network itself. But at the same time, please remember that blockchain is a logically centralized platform. What do I mean by logically centralized platform is that it is a platform where all of the nodes have a common understanding about the state of the chain that we're talking about the status of the network, about the status of the transaction that is happening. Now, moving on, there are four important pillars. This is just a theoretical concept. I'll try to finish it up as soon as possible so we can move on to and do some real things out there. Now, first is the cryptographic tokens. Cryptographic tokens are what you like to call as Bitcoin as well. Bitcoin is a token which has some value associated with it. So, cryptographic tokens essentially means that a token is a verified unit which has a quantified value associated with it and is recorded on a blockchain. Along with that, we will be talking about peer-to-peer networking system in a bit more detail because it's the core of blockchain and consensus forming algorithm. I hope you remember the proof of work that I told you about. We'll be going in deep in details about consensus forming algorithms and Turing complete machine. With virtual machine, it essentially means that the machine, the platform, like it is independent of hardware and can run any kind of. So now, when we're talking about tokens, it can be anything in nature. It can be your likes on social media, it can be your electricity unit, it can be your currency, Bitcoin and Ether. It can be practically anything. Now, peer-to-peer networking system allows us to do a lot of things in network. And one, like some of the main benefit that it has is that at the end of the day, what blockchain enables us is that we get a database that is secure with automatic trust. We are trusting open source code encryption there. And the data is tamper-proof in nature. Once information is put into a database, it cannot be changed and it cannot be altered afterwards. It is a shared database, which means that many people across the network have a copy of what is continuously being updated and what is happening. Likewise, it is transparent, means everyone can see all the transactions that are happening and what is being done, and transparent in nature. Decentralized, that we've talked enough about decentralization, it means that there's no central authority governing institution or anything like that. Now, let me give you an example of blockchain, what it can offer to world. Now, when we're talking about ledgers, companies, let's say we have two companies, A and B. How will you know that something happened? How will you know that there was a transaction between a receiver and a sender? For that, you will have to look at two ledgers. First one will be the ledger of the sender, which mentions that they have paid something, and second you should be looking at is the ledger of the receiver. What blockchain allows you to do is it allows you to have a triple entry system. Now, if there is a paid and there is a received, we don't have any discrepancy here, right? What blockchain allows you to do is it allows you to have a triple entry system, which essentially means that this will be a distributed public ledger. Remember, I talked about it when we were talking about definition of blockchain. And what it allows you to do is have a public grounds on which you can verify anything that happened. Now, although this seemed very trivial and very simple thing to do it, what we just did with this triple entry system was we created an audit. And right now we are paying billions of dollars to the or be it your PWCs, KPMGs, or they are earning money out of it. And they're just literally doing nothing, just confirming that transaction. So this is what decentralization and blockchain has to offer to everybody in the network. So there will be still credits and debits, but we're going to have a third immutable ledger entry. It's immutable in nature, and we've talked enough about immutability. Now, there is a very important concept of trust here. In our world, when we're talking about trust, we are talking about centralized institution. If you look at the 100 rupee note that is provided by RBI, you realize that there are some lines written over there that claims and says that this piece of paper can buy you something worth of 100 rupees. But how will you get that value when we are talking about decentralized system where everybody can do anything they want with the network? So the question remains is, without any third-party institution, how are you going to do it? Let's take a scenario, for example. Let's talk about a party where we have around 16 individuals who are sitting together and having their good time. Now, what they decided to do was they decided to have a game. And in that game, all of the members, all the 15 individuals are going to put in 1,000 rupees each, and they're going to pull out a chit, a lucky draw kind of a game where the name that is there on the chit gets all the money, right? So if I am a part of that group, and if you are a part of that group, and when you are putting in that money, whom are you trusting there? There is no central figure who is looking after everything that is going on. There is no person sitting there and monitoring everything. Oh, this did not happen. Now, who are you trusting there? You're trusting the entire set of people there. You're trusting everybody who's there. You're trusting the entire network. And that is what decentralization has to offer to everybody. That is the level of trust that we're talking about when we're talking about trust and decentralization. And whenever you study about all these things, you'll realize that this trust is established through cryptography, through protocols, through computer code. Now, moving on, let's. Yeah. So, how can you interact with a blockchain network is via a wallet. It's a Bitcoin or Ethereum wallet. I'll show you a real wallet in a little while. So, a wallet has three components. It has the address, and it has two very important concepts called as, a public and a private. So, what happens is that if you have a private key, things are going to get a little bit technical from here on out, so please bear with me for a few minutes. And after that, we'll move on to a very practical demonstration of what is happening. So if we have a private key and how it is generated, this is a technical aspect of what we're going to talk about right now, right? So it goes through mathematical algorithm, then you have your public key, then you hash it, and then you get an answer. Now, what is the difference and how you can just simply say that I have the address. I can simply reverse the function and get the public key. And if I get the public key, I can get the private key. So first let's try and define what these public and private key and addresses are. So private key is something that is secret to me, because if you don't want your funds stolen, then you have to keep your private key to yourself. Public key is something that is available to everybody in the network. And address is the address of the wallet. And when we're talking about all these hash functions, we are talking about one-way functions. And there is a reason why they're one-way functions. I'll explain it to you. So if somebody is interested in knowing how these algorithms, wanted to read about them in details, these are the algorithms that are used. Now, ECC is used by Bitcoin and so on and so forth. Now, moving on, back to public and private key pairs. Now, let's say we have an individual, Ayushi, who wants to send a message. Hi. Now, there are two things that do. Public and private keys are used for encrypting and decrypting the data. What happens is that if I have my private key to myself and you have my public key, then you can send me the data and I will be able to decrypt the data. Now, decryption happens only with the help of the private key. You cannot decrypt just because you have my public key. Now, this message was encrypted using the individual's public key, the individual that we are trying to send money to. And it turns into a ciphertext. Ciphertext is something that human can understand by looking at it. Comes from keys, ciphers, technique of encryption. Now, decrypting the data happens with the help of a private key. Now, what Ayushi just did was she encrypted the data, which turned into a private key. And if she wants to send it to, let's say, Bhavya, then what she has to do, Bhavya will have to do is decrypt the message using the private key. Now, this is how the entire circuit works. You encrypt it using public key, it gets coded into a ciphertext, and you decrypt it using your private key. Now, this is not the only way that you can use your public and private key pair. You can also use it for something called as digital signing. Let's say if I sign a document and I encrypt it using my private key, and I allow everyone to decrypt it using my public key. Remember, public key is available to everybody in the network. So if that happens, then anybody in the network can be assured of the fact that since I have my private key, then I am the one who signed the document. Now, this is how it happens. You encrypt the data using your private key, it gets converted into a ciphertext, and it can be decrypted using your public key. This makes sure that you are the one who sent the document, you are the one who sent the cryptocurrency or whatever form of token that we're talking about. Now, if you want to read about more about it, it's available on the internet. Now, moving on, please remember that hashing and encryption are two very different terms, and most of people like to confuse them and like to use them in a similar fashion, which is not the right thing to do. Why? Because let's take for example multiplication of 12 and 10. You get 120, right? But this is what we call as a function. We're multiplying 12 and 10 and you're getting some result. Now what happens if I only give you 120? Can you be assured that you are multiplying 12 and 10 when you're getting 120? It can be anything. It can be addition of 120. It can be subtraction of 140 and 20. It can be multiplication of 30 and 40. Now, this is how hashing works in real life. When we're talking about hash function, why are we saying that it's a one-way function? We're saying it because there is no way to go back in time and to look at what were the inputs. Now, if you have a particular input, you're always going to get a same result. If you have a multiplication of 12 and 10, you're always going to get 120. But if you're getting 120, that doesn't necessarily mean that it came from multiplication of 12 and 10. I hope this is understandable. Now, let's say blockchain has been making some very big claims when we're talking about hashing and all. They say that it is completely immutable in nature and you can just not go back. You can argue with the fact that, okay, I can just try every number that is out there and add, subtract, and multiply. So when we're talking about such things, we're talking about the real life hashing algorithms that are used, which is your SHA 256. SHA is your standard hashing algorithm, which is used by Bitcoin and Hyperledger Fabric. And you have KIIT 256. Now, what does this 256 mean? It means the number of bits that are there, right? Now, if you have 2 to the power 2, you have 4 possibilities and 4 different answers to it. When you have 2 to the power 3, you get 8 different answers to it. Now, what will happen if you have 2 to the power 256 combinations possible? Now, what is the biggest number that you can pronounce? I'm not sure, but I was not able to pronounce this. This is technically the number which is bigger than the number of atoms that we have in the universe. And those of you who are worried about the collisions that might happen here, it is 1 in a 115 something. I don't even know, 78 digit number, and I don't even want to try pronouncing it. It's just so difficult. So this is why when we're talking about hashing, we're talking about immutability. And even if you have the world's best supercomputer that is in there today, it is going to take you unreasonably, large amount of time. It dates up to hundreds and thousands and millions of years for you to actually crack an SSH 256 hash and get the inputs out there. Now, let's talk about mining. So somebody was asking questions about mining. Who are miners and why are we trusting them? And we're not trusting them, we're trusting the system itself. So you can be a miner, I can be a miner, anybody in the network can be a miner. What is their job? What they do is they verify a transaction. They broadcast the transaction and to solve a puzzle to gain the right to claim a transaction. And in return, why are they doing all these things? Is because they are getting a lot of money out of it. We'll be talking why they are called as miners, because there is a reason why they're called as miners. So when we're talking about miners, please remember that mining, the proof of work consensus protocol that we had talked about, it requires tremendous amount of energy. And this is where the issue of scalability comes into picture as well. Statistically speaking, 1 year of mining around the globe takes around 1.2 billion US dollars amount of money, which is more than the energy consumption of some countries like Denmark. So please remember that proof of work is not the best best consensus protocol out there, but it has been used because it was like the first thing that people knew about. And right now with Ethereum 2.0, we're trying to use different consensus protocol. It's a different consensus protocol called as proof of stake. Now, before we move on to proof of stake, proof of work, yeah. So here I'll be asking, answering your question about what difficulty is and what are the puzzles that we're talking about. Now, this is a technical aspect and it's been done from a miner's point of view. You have a block-headed element, which is a constant, and you have nonce, which essentially means a variable. What you as a miner will try and do is you will hash them together, let's say H, right? And now you will compare this to the difficulty. Difficulty means that difficulty is nothing. Difficulty essentially means that an arbitrary setting that determines how hard it is to create a block. This is where all the value comes into picture. If everyone creates a block and throw them in the network, then there will be no value associated with it. Now, what Ethereum does is that after you hash it, miners compare it. If you have a hash and it is less than the difficulty level of the block, the puzzle is solved. But if it is not, then you change the value of the nonce and redo the entire consensus, entire process of mining the block. So this is how block mining works, and this is what proof of work is. Now, talking about proof of stake is completely different concept. We'll not go into the technical details. If you have any questions specifically, you can leave in the comment section. I'll answer them at the end of the workshop. And apart from that, you can see this CBFT, and these are used by Hyperledger Fabric, and this one is used by your Ripple network, right? You can read about more about it in the link that I shared. Now, moving on, why you see when we're talking about cryptocurrencies or an exchange of values, there is something very important that we're missing, right? What we are missing here is the conditions, right? If you want to buy a coffee, you might not just be able to do it because you have to make sure that you have the right amount of sugar associated in that coffee, you have right amount of, milk in it. If you want to drink an espresso, it should be up to your taste levels or not. So these are all the conditions that we're talking about here. If you want to send a bouquet, you are associating some conditions like I want to have yellow tulips, or some conditions like you want to, renew some of the credentials in your driving license, and so on and so forth. These are called as conditions. And what the second generation of blockchain had to offer to all of you was an ability, a very powerful tool to make sure these conditions are fulfilled. And we call them smart contracts. Now, smart contracts, they're not very smart, they're not really contracts. They are just piece of code that is out there in the network, which was first introduced by Ethereum and then it's now been used by a lot of blockchains. So smart contract is just a piece of code that has been baked. I don't know why it's called baked, but it's been baked in a block, and it's permanent. And basically, all the negotiation and all the conditions that you have associated with the transaction or associated with the record, you can achieve it with the help of smart contracts. Now, I think the time is not permitting us to move any further in detail about the smart contract because I want to show you how you see a real blockchain works. So we'll be quickly finishing up with the smart contracts. And if you have any doubts, you can ask me. So this is what smart contract basically means. You have a contract which has been baked into the block, and now you can, as individual, cannot change anything. If it has been defined as a certain condition out there, then it has to be that way. You can have conditions, you can have policies written on a contract, you can have regulations written on a contract. So is there any doubt in smart contracts? Okay, since nobody has any doubt in smart contracts and how smart contracts work, smart contracts allows us to build something called a decentralized application. What a decentralized application? Decentralized application basically means the new version of app that you're going to have in your phone in next 20, 30 years. So basically it's decentralized application. So I will quickly end this here and we'll move on and explore a real blockchain. So before that, if anybody has any issues or if you want to ask anything for that matter, any questions?
Do you have any sample smart contracts that you have written, which we can use for reference?
Yes, I have them. I'll show it to you in a minute. Writing smart contracts is not very difficult. You can write it yourself. So if not, then maybe we can proceed with practical implementations and I can show you how a real blockchain works. Is there anyone who has any questions? Just a quick yes or no one. Is there any question you have? No, probably not. So moving on, I'll show you what a real smart contract looks like and how a real block works. So bear with me for a minute. I'll show you in a second. I hope my screen is visible to everybody. Now, this is a remix Ethereum.org website, basically an IDE where you can write your own smart contract. Now, this is a sample smart contract. But this is not what I want to show you. This is something that you can find easily on the internet. What I want to show you is something different. You see, this is what we call as a wallet. Now, a wallet is something that allows you to store your um, money in it, and whenever you're playing around with wallets and Ethereum, make sure you're doing it on testnet and not on a mainnet. Mainnet is where it is called cost real money. And if you're just playing around with it, you can use the Robson test network and also purely test network. I use the good one. It's nice. It works fine. You can do about anything with it. Now, this is what smart contract looks like, and this is where everything starts. So before we move on to a smart contract, what I want to show you is a coin-based transaction. Now, this is a transaction. You can find it anywhere. I've logged into btc.com. You can find it essentially. There are a lot of websites there. Now, in a Bitcoin transaction, you have some input and you get some. We call them UTXOs, unspent transaction output. Now, you can see the number, like if I have one input, it doesn't necessarily mean I have only one output. The number can differ up to anything, right? So this is what UTXOs are, and this is what blockchain takes as input. But if you look at the first transaction of any block, you will see that there are no inputs. So what is happening here? This is a coin-based transaction. Now, in real world scenario, you have RBI who has the authority to print money, right? So where does all this cash and all these things come from, and where does all the coins are coming from? They're coming from here. This is a coin-based transaction. What happens is that the miners fee, the fee that miners receive, comes from two sources. First is your gas. Gas fees is something that whenever you're deploying a blockchain or you're deploying a smart contract on the internet, you will see that there are certain amount of money. Like if you're sending 5 BTCs, you're sending a very small amount of money associated with it. So this is what a coin-based transaction is. This is why they call it miners. They call miners because this is where the money is coming in. This is where the actual paper is going into the machine, and the rupees and all the notes are coming out of. So this is where the money comes into the network. This is where everything happens. Now, this is basically a reward that miners give to themselves, and it combines of both your coin-based transactions. For right now, it's around 12.5 bitcoins that are given to the person who mines the transaction, the miners, along with the gas fee that is involved, that that is generated from all of the transactions. There are around, you know, around 2,000 transactions per block, and along with that, what I'm going to show you here is a hash. Now, what a hash is, like you can go to this website and see for yourself. A hash is this number, which we were talking about earlier. Now, a Bitcoin hash, block hash, starts with 19 zeros, but that is not the case for all every blockchain different. Now, let's say I have to type something. Let's say I have to type hi here, and then I press a space. You can see that the hash is changing, right? But if you go back and type something else, and then you come back to hi, you will get the same hash. And this is impossible to predict. This is practically not at all possible. If you want to find out what the hash of your, Indian constitution is, you have to, copy paste the entire constitution over here, and you'll still get a number this long and with a unique hash. You can never predict what the hash can be or might be. Now let's look at what actually a block looks like. Now, what we had earlier here is just the data. Now, this data has been divided into three categories. You have your block number, you have your nonce, and the data. Now, let's say I type in some words here, right? Now, you can see the entire background turns to red. Why? Because you remember the puzzle that I told you about? The hash combined with your nonce, you just need to change the nonce value and try it over and over again, just so you can get a hash that starts with 4 zeros for this website, but for Bitcoin it's 19 zeros. So you have to continuously type in various numbers, try to get something, somehow, 4 zeros, 4 leading zeros. So let's press on this mine button because we don't have so much of time and computational power that we can actually find what is going on here. So what this mine is doing is it is trying to, hash this data and the previous hash and trying to get some nonce out there. So you see it stopped at 85,000. So this is how a block works. Let me show you how a blockchain looks like and why is it so tamper-proof and why are we making such big claims. Let's say I go here and I type 1, which makes rest of the blocks invalid. So what if you want to tamper with blockchain, you will have to do the entire process of finding the correct nonce value, mining the block all over again, and mining the rest of the block as well. Now, this is what a peer-to-peer network would look like. This is a peer-to-peer network. We have a peer A, we have a peer B, and we have a peer C. Now, what happens if you change something here? Let's say we change something here, and we mine this block. It turns green. Obviously, we don't have any problem with it. What we will be doing here is that we will be mining this block, and then we'll again mine this block because the hash has been changed. But there is still one very big issue that is there. You can see the hash that has been generated here. It ends with your 74DS, but that is not the case for this hash, right? It ends with 27170. And similarly for this. Now, if peer A tries to change something in the network, then peer B and peer C, this is where the 51% attack concept comes into picture, that peer B and peer C will be able to identify that there is some malicious activity going on. I hope this is understandable to all of you what we try to do here. Now, we're talking about tokens as well. Now, I've told you about the Coinbase transaction, so I don't think it requires more explanation. Now, if you change anything out here, it's going to have the same effect. I'm not going to repeat everything because it really won't make any more sense than it has already. Now, let's talk about remix, right? And I told you how what all these things look like, right? Now, what I'll be showing you is how you can deploy a smart contract. Now, deploying a smart contract can be done with a wallet. Right now, I have a wallet of MetaMask. You can get this extension from your web store, and all you have to do is inject it. When you inject it, you can see the network that I'm on. And if you deploy the smart contract, it will ask you for a few things. Yeah, it will ask you for a few things, and since I have recently used it, it's not asking for the password, but usually does. And once you confirm the transaction, you can see here, you'll get this. Now, this is something that is happening in real time. My block, my transaction, the deployment of the smart contract is being mined right now in the real time. You can see it stays pending because it's not yet being mined and it's being mined. And we'll come back to this later on when it's mined completely. You can see that thing. But what I want to show you here is this part. I'll give this code to you guys and you can play around with it if you want to. This is simple wallet out there and you can see the logs. I hope the color is not that nice. So these are the logs which tells you what this is a smart contract, like from where, from this particular account to your smart contract, and this is the hash to your smart contract. This is how it works. This is how it comes into picture. Right? Now let's go back here. It's still pending. I'll try and refresh it. Yes, successful. So this is my block number. What I just showed you was a real, thing that happens on the internet, how your blockchain is actually being mined in real time. It has a gas limit. Remember the gas and the transaction fees that I told you about. It has a gas price, and you can see since I have sent the money to the smart contract, it's being says that I have sent it to a particular smart contract. Now that is it all about the smart contract. I cannot go into details because I think time won't permit it. We've already done a lot. So let's stop here. So that is it. Is there anything that you want to ask or anything? Or you want me to explain something in detail? Anyone? This is mine and that is where I cannot see anybody there. Yes, thank you all. I don't. Yeah, you're audible.
Okay, cool. Yeah, so I was telling that they're saving their questions for the next session.
Okay. All right. I did not know that. So I'm good to go back.
Okay, then we will just wrap up. Okay, so how many participants we have? Hey guys, thanks for joining us today in this workshop. And soon, Neha here will have her whole playlist on blockchain, from where you can learn more about the topic, and she will also explain few more things which we are not able to cover in this workshop. And thank you, Neha, for sharing your knowledge with us. We are glad that this workshop was a success and looking forward to have another session with you soon. Cool, everyone? Okay, then I think we can wrap up. Ananya, you can stop the recording, I guess. Okay, cool. Thank you, everyone. It was great seeing you guys. And the certificates will roll out soon with the details and the links to the PPT as well as the YouTube recording.